In Chapter 4, we will look into linear regression. We will investigate the relationship between two variables, a dependent variable and an independent variable. We will learn how to use correlation analysis to measure the strength and direction in a relationship between two variables. We will use the least squares method to determine the slope and intercept of a linear equation that best fits a set of ordered pairs. And we will learn how to calculate and interpret the coefficient of determination. Now, an independent variable, x, explains the variation, the change in a dependent variable, y. When you have two variables, x is always your independent variable, y is the dependent variable. Y depends on x, and you always want to predict the dependent variable based on the independent variable x. The relationship between independent and dependent variable exists only in one direction. We use the correlation coefficient to learn and investigate the strength and direction of the linear relationship between an independent and a dependent variable. Correlation coefficient, we use the letter R. R ranges from -1 to +1. -1 indicates a strong negative relationship, +1 a strong perfect if its R is equal to 1, strong positive linear relationship. So the range of values that R takes is from -1 to +1. When R is equal to 0, there is no linear relationship between the two variables. So that indicates that just knowing the value of R, and most importantly the sign of R, you are able to determine what type of relationship you have and how strong this relationship is between the two variables. The least square method is a mathematical procedure used to identify the linear equation that best fits a set of ordered pairs. The procedures involve finding values for B0. B0 is used as a symbol for the y-intercept. B1 is the symbol for the slope. In your graphing calculators, you will have the y-intercept as B and the slope as A. The value of y represents an actual data point, whereas the value of y with the little hat on top is the predicted value of y using the linear equation given a specific value of x. So when you are able to determine the equation that links the two variables, your dependent and your independent variable, you are able to predict y for a given value of x. The coefficient of determination, R squared, measures the percentage of the total variation of a dependent variable explained by an independent variable. A coefficient of determination equal to 0 means that there is no linear relationship between the two variables. The coefficient of determination is the square of the correlation coefficient. So if you have the correlation coefficient R, by squaring it, you will be able to find the coefficient of determination. R squared, and of course, since it's a square, takes values from 0 to 1. And once again, is the percentage of the total variation of a dependent variable that is explained by the independent variable. A regression equation provides a point estimate for a dependent variable given the value of an independent variable. And you are also given the formulas. You have the formula to calculate R. You have, we will learn how to use our graphing calculator, so you do not have to use the formula at all times. In all the problems that we will look into, I will be offering both solutions using the formula and using your graphing calculator, and as you will see it for yourself, using the graphing calculator is obviously a lot faster. The equation that links the two variables when we predict y is y predicted is equal to ax plus b. Once again, a is the slope, b is the y-intercept. The regression slope, the formula for the slope, you have it over here, and the formula for the intercept, you also have it here. Once again, we will be using our graphing calculator, so you do not have to use either formula for the slope and the y-intercept. The coefficient of determination, r squared, is simply the correlation coefficient squared. So once you have r, you square it and you get the coefficient of determination. Now, let's look at this, the scatter plot. What is the scatter plot? The first step in linear regression is to create a scatter plot. So a scatter plot, as you probably already know, is a visual depiction of the strength and direction of the linear relationship between the independent variable x and the dependent variable y. So basically, the information that you get from the scatter plot, you are able to also get from the correlation coefficient. So the scatter plot gives you the exact same information as r, which means strength and direction of the relationship. The following table represents the number of absences and the grades of the students in Math 252. Create the scatter plot. So we have the x values and we have the y values. There are two ways. You can use Excel. By using Excel, the following scatter plot is given, which indicates a strong negative relationship between the two variables. More absences, basically lower grades. This is how the scatter plot would look like. Now, if we were to use our graphing calculator, I have all the steps here. What we would do. Using our graphing calculator, let me just adjust the lighting. You would go to Stat, Edit. It automatically brings you to Edit, Enter. You have L1 and you have L2. Under L1, you will always be entering your x values, and under L2, your y values. So your independent values, x, will be going under L1. Your dependent values, y, will be going under L2. To find the scatter plot, to take a look at the scatter plot, all you need to do after you enter your values is go to Zoom. Zoom is the third top, on the top line, the third key, and 9. And this will give you the scatter plot. So once again, for the scatter plot, we enter our variables, Stat, Edit, L1, L2, and then Zoom and number 9. Now, if I wanted to find the correlation coefficient, the next step is to calculate R. A correlation coefficient R indicates, as we mentioned before, both strength and direction of the linear relationship between an independent and an dependent variable. It ranges from -1 to +1. If R is 0, once again, that means there is no linear relationship between the two variables. If R is positive, the scatter plot goes up from left to right, while if it's negative, the scatter plot goes down from left to right. So for example, in the previous example that we just did, if you notice the scatter plot, it goes downwards. The points have a downward direction from left to right, which would indicate a negative relationship between the two variables. Now, if we were to use the formula for R, the R would be equal to n times the summation of x times y minus the summation of x times the summation of the y values over the square root of n being the number of pairs that you have in your data set, times the sum of the squared x entries minus the sum of all x entries squared, and then all of that times n times the summation of y squared minus the summation of the y values squared. Make sure you use your parentheses the right way, and in order to use the formula, you would need to calculate x times y, x squared, y squared, and then take the summation of all the columns. So let's look at this example. Calculate the correlation coefficient and explain the relationship between the two variables for the following group of data. So we have the x and we have the y values. If we were to use the formula to calculate r, we would write down x, write down y, find the product of the two for each pair, so 2 times 5, 10, 3 times 9, 27, and so on and so forth. Calculate the squared entries for x, so whatever you have under x, you square it. These will be the numbers here, and you will do the same for the y entries. You simply square each y entry. At the end of each column, you find the summation because you will be using it for the formula. Once you have the summation of each column, you go back to your formula and you plug in the numbers that you have found. So in this case, r would be 0.914 is positive and is really, really high. Anything above 0.7 is considered strong, and r between 0.5 to 0.7 is considered fair, and an r that's below 0.5 is considered weak. Now, if you were to use your graphing calculator, you would go and enter your variables the same way we mentioned before. Stat, edit, L1, L2. Once again, L1 are your x, L2 are your y's. You would go to stat, calc, right here, and then you would go to number 4. Press enter. So as you see here, r is equal to 0.9138. If we were to round up to the third decimal, it would be 0.914. Same answer as we have right here, only a lot faster. Only a lot faster. So once again, you go to stat, edit, you enter your data, L1 and L2, and then you go to stat, calc, and number 4 to find r. You will use the same way to find r, r squared, your slope, and your y-intercept when you are creating the equation. And this is something that we're going to look into further on in the chapter. Now, once you find r, you will be asked and you will be interested in finding whether there is a linear relationship between the two variables. So when we're testing for linear relationship, and basically we're testing if r is significant, we have to perform the following steps. The first step is to determine the absolute value of r. That means even if you end up with a negative r value, you still take the absolute value. Once you have the absolute value of r, you will go to the table. You also have this table in your slides, the PowerPoint slides, and you compare n to, so if the absolute value of r is greater than the critical value, a linear relationship exists between the two variables. To find now the critical value, you will go based on the number of pairs of data you have in your data set. So if n, for example, is equal to 5, your r will be 0.878. So in the previous example that we just did, we have how many pairs of data? We have 5 pairs of data. 1, 2, 3, 4, 5. So n is equal to 5. You go to your table, n is equal to 5, so the critical value is 0.878. You will take this value and you will compare it to 0.914 right here that we just calculated r to be. Since r is greater than the critical value, you can safely say that there is a significant linear relationship between the two variables. Therefore, R is significant. This is how you will be using this table to determine if there is a significant relationship between the two values. Now, let's see how we will be forming the equation that links the two variables, the dependent and independent variable. The least square method is a mathematical procedure used to identify the linear equation that best fits a set of ordered pairs. The procedures involve finding values for beta, which is your y-intercept, and alpha, which is the slope. The value of y represents an actual data point, whereas the value of y with the little hat, as I call it, is the predicted value of y using the linear equation given a value for x. Now, we focus on the simple linear regression equation, which is based on only one independent variable and one dependent variable. In theory, you may have multiple independent variables. However, in our case, we will only cover a simple linear regression equation where, once again, we have one independent and one dependent variable. The equation is y predicted is equal to ax plus b, beta. This is the formula that we will be using. So the predicted y will be equal to alpha a, which is the slope, times your x value, plus beta b, which is your y-intercept. You also have the formulas for the slope and the y-intercept that you can calculate by, but as we mentioned before, the easiest way is to go to stat, enter x, y values, you go to stat, calc, and then you go to number 4. Let me just adjust the lighting. You go to number 4, enter. So in this case, you have your A, your alpha, you have your B, beta, and you can just form your equation y predicted is equal to ax plus b. Once again, A is your slope, B is your y-intercept. For the y-intercept, make sure that you always include the right sign as given to you in your calculator. Let's look at this example. So, calculate the linear regression equation for the following group of data. You have your x values, you have your y values. If you were to use the formulas given to you, once again, you create this table where you have your x, your y values, the product of x times y, and the square of the x values. And all you really need to do is substitute these values in the formulas given to you. Keep in mind that in our case, n is equal to 4. We have 4 pairs of data. We have 4 pairs of data. Now, if we want to use our graphing calculator to find the equation that links the two variables, you will go to your graphing calculator. You will highlight L1, L2, press clear and enter, not delete, because delete will take the whole column out and you don't want that. Clear and enter. This way you erase previously entered data and you enter the new one. We said that L1 is your x values, has your x values. So in our case, we have 3, 4, 6, and 7. And then L2, your y values, we have 10, 12, 15, and 20. Once you enter your data, and you want to be very careful how you enter your data, you go to Stat, Calc, number 4. So, these are the new numbers. You have your slope, 2.3. You have your y-intercept, 2.75. you're also given r and r squared if it's needed and if you are asked to calculate it. So based on the equation that we have, y predicted would be equal to a times x, alpha times x, which is 2.3 in our case, 2.3x plus your 2.75, which is the y-intercept. And this is how you would write down your equation, same way as, if you notice here, this is exactly the same as we found using the formulas, only a lot faster, obviously. Now, when we predict y, so you will have problems after you create the equation asking you to predict y for a given value of x. The most important thing to remember, as a process, it's very, very simple. You go to your formula and you substitute x for the given value that you are asked to find y for. However, you can predict y for x values that are between x minimum and x maximum of your original data values. So once again, when you are asked to predict y for a given value of x, you always double check if the value given to you is within the range of x minimum to x maximum of your original data values. That means if I ask from you, in our case, in this example, to predict y when x is equal to 5, you could have done it because 5 is between 3 and 7. If I had asked you to predict y given x equals to 10, you would not be able to do it because 10 is higher than your maximum entry, which in this case is your 7. So you would have to state that you cannot predict. Now, an example here. I want you to predict y when x is equal to 5. As we mentioned before, x minimum is 3, x maximum is 7, 5 is within the range. All you have to do is go back to your equation, plug in 5 for x, do your calculations, and you find that when x is equal to 5, y will be equal to 14.25. The last topic for this chapter has to do with the coefficient of determination. The coefficient of determination is r squared. It measures the percentage of the total variation of a dependent variable explained by an independent variable. When a coefficient of determination is 0, that indicates that there is no linear relationship between the variables. The range of values that r squared takes obviously is from 0 to 1 since it is a square. And if we want to calculate the coefficient of determination, if the correlation coefficient is 0.96, all we need to do is square 0.96, and we will find that r squared is equal to 0.922. So if r squared is 0.922, that means that the predictions made with y predicted is equal to ax plus b equation are 92.2% accurate. Technically, 92.2% of the variation of y values are explained by the variation of the x values. Now, if you were to use your graphing calculator, just like we mentioned before, once again, you go stat calc number 4. This is the screen that you have here. Let me just make sure that you can see it. And r squared will be, in this case, 0.9322. But this is where you would find your r squared as well. Or if you were given r, all you have to do is simply square it. And this concludes the notes for chapter 4.